All right, we're going to make this one super fast because I got a baby that's ready to go to sleep. Here we go, solving basic inequalities with yours truly, Mr. Slagle. All right, let's take a little peeksy-weeksy here at what we got. I'm going to jump up here, take a look. Remember, an inequality looks like something like, hey, look at this. X is less than 9. How many solutions does the inequality x is less than 9 have? Now, an inequality, if I were to say x equals 9, that is equation because it is expressing equality. X is equal to 9. Here we're saying x is can be equal, but it's actually less than 9. How many solutions are less than 9? How many numbers are less than 9? Ooh, there's a couple. Yeah, 8, 7, 6, 5, 4, 3, 2, 1, 0, -1, -2, -3, -5,000. How about 1.2, 1.0000007? There are a lot of numbers that are less than 9. So the answer is they're an infinite number of numbers that are less than 9. Okay? This is an inequality, and they have lots of solutions. Okay? Equations can also have lots of solutions, but linear equations usually just have one solution. Inequalities usually have an infinite number of solutions. Okay? Next question. Can I change the order that I write an inequality? The answer, of course, is yes. Okay, x is less than 9 is the same as saying 9 is greater than x. However, please be careful, because I prefer this method. It's I think easier to read, and it helps us graph a little bit easier. Saying x is less than 9 or 9 is greater than x, all that does really is like if we were talking about me and my brother. I'm a little bit taller than my brother, so if I said Mr. Slagle is taller than his brother, we'd be kind of saying the same information if I started with my brother and used a different comparison. So if you change the order that you're comparing things, you got to change the inequality. Mr. Slagle's brother is smaller. I had to change the word that I used than Mr. Slagle. Okay. I'll leave his name out of it because he might still beat me up. I'm a little worried about that. All right, let's move on. All right, what I'm going to do here is we're going to run through these inequalities. I'm going to go through really fast. You can pause and rewind and do what you need to. This is less than. This is greater than. This is less than or equal to. Okay, that is all that is this plus one more value. This is greater than or equal to. Fantastic. Now let's see some examples and let's graph them. All right. I say, let's start with something simple. X is greater than 1. I'm looking for all the numbers that are bigger than 1. So what I'm expecting on your graph is this number right here I call the boundary. It's the boundary. It is the boundary between where solutions are and where they're not. Okay, it turns out to be at 1. So sometimes I'll put, if the boundary is a whole number, I'll usually put it in the middle, and I will put, that's going to be kind of the center of my graph. It's a fraction, I might not, and you'll see some examples of that in just a sec. Now you can number this 1, 2, 3, 4, like you normally would think, 0, -1, -2, so on and so forth, -3. I'm really just looking for maybe around 5 labels, 4 to 5 labels on your graph. That's enough for me. Less than and greater than on graphs, we typically use an O like this. It's an open circle. And the open circle indicates that the boundary is not included in our solution set. Or, put simpler, 1 is not bigger than 1. So you put a circle on your boundary. If it's one of these two, you will use a closed circle to indicate that the boundary is included in our set of solutions. And then you really shade the side that makes the inequality true. So you could plug in one number from each side. If you plug it over here, is 3 greater than 1? Yep, that makes it true. So all of my solutions go from a little bit bigger than 1 all the way up to, make sure you draw an arrow, all the way up to infinity. Got to put that arrow on there. Okay, super. If you plug in something like 0 or -3 is not greater than 1. It is less than -1. So less than really means to the right, or sorry, to the left on the number line. Greater than really means to the right on the number line. Did I do greater than? God dang it. All right, we're going to swap those really fast. I'm just going to go like this. Here I am teaching in my video about stuff. Look what I just did. Aren't I clever? I wonder if I did that in class today. Probably did. Real smart, Slagle. I am resourceful, though, you have to admit. Let me drag that on down. It will be quick, I promised. Nice and fast, the lesson, this one. Okay, yeah, so this is our boundary. Let's do another one. Let's do, up here, I'm going to do x is less than, let's do -4/3. All right, -4/3 is between two whole numbers. So it's between, so maybe we'll put 0 there, and then maybe this is -2, and you can skip around a little bit. You don't have to write every single number if you don't want to. That's -4. -4/3 as a mixed number would be -1 1/3. So where is that on our number line? -1 1/3. Well, there's -1. I'm going to go over just a little bit, and it still has the open circle, 1 1/3. And then we can test a number. Is 4, it is 0 less than -1 1/3? No, it's bigger than because it's to the right. So really what we do is if x is on the left, you just shade the direction that the arrow is pointing. But really beware, because if you have the inequality flipped around, you're going to graph it the wrong way. So the mathematical way is to plug in a number and check. The real short trick way is to make sure your variable's on the left and then shade the direction that the arrow is pointing, which is this way. Super. Let's do a couple more. Let's do x is less than or equal to -55. Remember, when you're on the negative side, they're kind of counting, when you're counting up, the numbers are really getting less negative. So if we have -55 in the middle, and you go over, let's say 1, 2, that's going to be -53. You're counting towards 0. -57 here, -59, so on and so forth. 55, 56, 57. Yep, so throw a couple numbers on there. This is going to be a closed circle at 55. Since it's pointing to the left and x is on the left, we can shade to the left with a closed circle. The last one would be like x is greater than or equal to 2.25. And I just wanted to remind you that if you're doing something like this, you can make your tick marks worth a little bit more if you want. So like this could be 2.5. Each tick mark is worth, so like each tick mark here is worth 1, here it's worth 1, here it's worth 1. You can spread them out, and you can make this like 3, and this maybe 1.5, so on and so forth. 2.25 then would be right here with a closed circle going to the right. And another little tip is you can make you can go the other direction too. We could have done, let's call this -55. And then we could call this -45 and make each tick mark worth 5. I like spacing them out like that because then the numbers aren't so close and crammed together when you're doing your graph. Okay, cool. Let's do some examples. So when you're solving, you're going to need to remember this rule. I'd like to give a brief explanation for why that works. But the rule is when we multiply or divide, those are the key words, when you multiply each side of an inequality by a negative number, we must change the direction of the inequality. Okay, I'm going to solve one first, and then we're going to come back and I'm going to explain why. Okay, so here we go. X divided by -7 is greater than 4. I'm looking for numbers that I can plug in for x that make this equation true. So to solve, it's just like solving an equation. We just have to remember that one rule. If we multiply or divide each side by a negative number, that means we have to change the direction of our inequality. And that's what I'm about to do. I'm dividing by -7, so to undo that, I'm going to multiply by -7. Okay. When I multiply the left and right side by -7, these cancel. Now I already broke my rule, I need to make sure, since I multiplied by a negative, that I change the direction of the sign. Coming down, those cancel, you get x is less than 4 times -7 is -28. For those that didn't see that, when you multiply by or divide by a negative, you gotta change the direction. It was a greater than, now it's a less than. So my solutions are any number that is less than -28. You'll notice if I plug in, so here's our solution, right? If I plug in our answer to check, let's pick something less than -28. Notice if I pick something like -35, that I chose that because it's divisible by 7, and I plug that in and do -35 divided by 7. We're asking the question, is that greater than 4? -30 divided by 7 is 5. Is 5 greater than 4? Yes, it is. So this works. Our solutions are correct. We can plug them in and check. How many numbers make this true? Anything less than -28. So -29, -28.5, all of those things are going to work. The closer you get to 28, the closer this number gets to 4, or -28. Perfect. All right, I also want you to graph your solutions. So here's what I'm looking for on your graph. Middle tick mark, number in the middle, -28. Count up a couple tick marks on the right, a couple tick marks on the left. -29, -30. Basically, do you know how to order your number line? Do you understand that we represent this with an open or a closed circle? So this is going to be less than, so we're going to do a closed circle. X is on the left and the direction of the arrow is pointing to the left. So I'm going to shade to the left and make sure you know that goes on forever. Let's keep going. You can try this one, try and do it on your own, try and solve it, try and graph it, and then I'm going to solve it. So here we go. Divide both sides by 3. I divided by a positive, not a negative, so I don't have to change the direction. 3's cancel and you get x is less than or equal to -11. That's my solution. How do I graph? Line, -11 in the middle, -10, -9, -12, -13. Closed circle because it has an equal sign. And then we're going to go to the left. Fantastic. Next question. Okay, inverse operations, just like solving an equation. If that said equals, we'd be adding 2 to both sides. +2, +2. You end up here with 13 is less than y. Now, if you try and graph this, the arrow is pointing to the left, but remember it's not in simplest form. I want you to flip that around, change the direction. You can change the order of an inequality. That was something that I did on the very first page. Okay. Now I want to explain to you guys why, when you divide by a negative, why do you change the direction? So if you pick a number bigger than 2, right? So normally with an equation, if I said 6 equals 6, and then we multiply both sides by -1, what you do to one side, you do to the other, right? Okay. Multiply by -1, you get -6 equals -6. Hunky-dory. This is true. This is true, right? If I get 6 is greater than 2 and I multiply both sides by -1, and I keep the direction the same, which I'm not supposed to do, you end up with -6 is greater than -2, which this is wrong, right? This is true. 6 is greater than 2. This is false. And then if you look at the number line, here's 0, here's 2, here's 6. Greater than means to the right on the number line, right? 6 is bigger than 2 here. but the numbers are counting in the opposite direction on the other side of the number line, and negative 2 is bigger. So basically, the right number is the 2 now, right? So since they swapped orders, since the 6 is on the right here and it's on the left over here, we have to change the direction in order to make it true. So this is currently false, but to make it true, we erase, and change the direction. Negative 2 is bigger than negative 6. All right. All right, let's take a look at a more complicated one. The first thing we're going to do with this one, if you guys want to try, be my guest. First thing we're going to do with this one, though, is we are going to simplify that right side. So you're going to distribute the 2, negative 2, and you'll get negative 2w minus 6. We could try and add these terms together, but this is a fraction. So the first thing I'm going to do is get rid of those fractions by multiplying by the least common multiple of the denominators. There's only one denominator, and that's 4. So I'm going to multiply both sides by 4. 4 times w over 4 is just w. 4 times 9 is negative 36. 4 times negative 2 is negative 8w. 4 times negative 6 is negative 24. Okay, we want to get these two terms together. I'm going to deliberately choose the harder direction, just to remind you. I'm going to subtract w from both sides. There's multiple ways to do this. You'll get negative 36 is greater than or equal to negative 9w minus 24. And then I need to get these two constants together onto the same side. So I'm going to add 24 to both sides, add 24, and you'll get negative 12 is greater than or equal to negative 9 over w. Now I need to solve this equation, which means I'm going to need to divide both sides by negative 9. When you divide both sides by negative 9, you're going to have to change the direction. So you're going to get negative 12 divided by negative 9 is less than or equal to w when you divide both sides by negative 9. Okay? Now this can be simplified, negative 12 over 9. You guys don't like my simplification method, but I sure do. Negative divided by a negative is positive. 12 broken down into its prime factorization. 6 times 2, 2 times 3, right? If we want to cancel this baby out, well, I guess I'm just going to simplify instead of going to this big larpy long thing. They're both divisible by 3. So you can divide the top by 3 and the bottom by 3, and you'll get 4 over 3. So w is bigger than, 4/3 is less than or equal to w. Let's go ahead and change the direction of that inequality to get w is greater than 4 over 3. That's our answer. And I think we even graphed something similar, but just a quick sketch of what that graph looks like. That's going to look like 0, 1, 2. I'm going to change that a little bit. Let's try that again. I put it in the wrong spot. 0, 1, 2, 3, 4. You kind of want the bubble to be somewhere in the middle. 4/3 is 1 and 1/3. Closed circle pointing to the right. I need to graph any of these other ones. Y is greater than 13. Yeah, this one you need to be careful. If you're graphing this, which one of these directions you use. We use this one because it is because y is on the left. All right, so that quick drawing is going to look like that. 14, 15, 12, 11. Great. Trying to model good behavior here. All right, you guys can try that one, and then I'm going to solve it real fast. Try it on your own. Let's get the constants together. Plus 8 plus 8. 22 is less than negative 2x. Divide both sides by negative 22. Did we switch the sign? We did. Okay, and then we switched it back. Yeah, we're good. All right, so same thing over here. Divide by the negative, and you're going to get divide by negative 2, divide by negative 2, you'll get negative 11. You've got to change the direction of the sign. Negative 2 divided by negative 2 is 1, x. So x is less than negative 11. Fantastic. And the graph, I'm going to be bad on this one. -11, it's going to be open circle to the left. You put the rest of the numbers on there. Okay, we say verbal inequalities all the time. When you say, I have at least $20, what does that mean? At least $20. At least. Think about numbers that make that true. If you have $10, do you have at least 20? No. If you have $30, do you have at least 20? Yes. If you have $20, do you have at least $20? Yes, you do. So, at least is actually greater than or equal to. And a lot of people get that confused because it says least, which sounds like less, but it's not. The least amount you would have is 20, which means a solution set or things that are greater than 20. You can do at most 40 push-ups. At most 40 push-ups, 40 is the maximum. So our solutions are less than 40. And it turns out greater than 0 because you can't do negative push-ups. Okay, try and take a guess and see if you can write these inequalities. Just by looking at the graphs, pause it, give it a shot. Here we go. I'm going to say x is less than or equal to 11 in this case, and then down here we have x is greater than 4 because it's an open circle, and this one is closed. Okay, my last little bit of advice here. If you're solving an inequality, we have two like terms here that we can simplify. 7 minus 1 is 6m plus 7. If you get to a scenario where I switch to w's, golly gee, I'm tired. 6m minus 6m, 0, 0. We get the statement -5 is greater than 7. Is this true? No, this is false. If you get a false statement, your answer is no solution. Okay, there is no number that could possibly make this inequality true. There's no number I can put in for m right here that will make it true. Okay, similarly, if I did a different problem and got a true statement, and I'm going to pick a kind of a weird true statement, but like -45 is greater than -100. Believe it or not, this is true. If you get a true statement when you're done, all real numbers are solutions. All real numbers are solutions to that. So we kind of went over that before. True statement, all real numbers solution. False statement, no solution. And there are some of those on your assignment, which is on Google Classroom. And that's it. You have that sheet. There are some selected problems that you can check. Thanks for working hard, and we'll see you next time.